Hello again, everybody, and this is a tutorial about a short to ground or a short between 2 points, what the difference is and which one actually will change the circuit. And you'll see what I mean. Take your basic circuit over here with your bulb over here. This could be a headlight, this could be a brake light. Simple circuit from one wire from the positive to this to the bulb. Current flows here, comes out the other side, goes to here. Now you see that this is the ground and this is the ground, but there is no connection or no wire in the schematic. But it's understood that the ground over here is connected to the ground over here. This could be an engine block or it could be anything that it's connected to, as you can see over here by this. As long as the path for current has somewhere to go back to negative. Now I drew a short over here. If there's a short over here, meaning it bypassed the load, it bypassed the bulb, current takes the path of least amount of resistance. So even if there's 10 ohms here or 9 ohms, whatever there is, 3 ohms, this is still much less compared to this. So current will flow here, come to this point and say, okay, I can either go to the bulb or I could go through the jumper wire. It'll take the jumper wire. That is the path of least amount of resistance, and it goes right to ground. Now, obviously, in this just a simple circuit, there is no fuse. So what we're doing is when we put this jumper across this, we're actually jumping across the battery from positive to minus, and obviously that's not a good situation. That's why you need a fuse protection. How much will be on the bulb? 12 volts here, 0 volts over here, because the other side goes to ground. How much did I lose across the bulb itself? If you have 12 volts here, you have 0 volts. I lost 12 volts across this. Now keep this in mind, this is a short to ground. So all the current flows through a short to ground. Let's look at another example. This is a little more complicated. It's two bulbs in parallel. Now, the same thing, but we put a fuse here. So the battery is here, and this is a short to ground. Remember, this is a short to ground over here. You put this over here, current flows here through the fuse, coming out the other side of the fuse. When it comes to this point, the current splits. It has two paths to go. One here and one here. And then back to ground. Fine. In this situation, this picture over here, they put a short. Look where they put the short. They put the short from here to ground. A direct short to ground. Now, since they did that, we always have to start with current flow. That's why I always teach current flow. A direct short to ground means this is the path of least amount of resistance, 0 ohms. Therefore, the current will flow, come here and say, okay, do I go through the light bulbs or do I go through here? Guess where it goes? All the current goes here. This is 0 ohms compared to whatever this is, 10 ohms or 5 ohms or 3 ohms, whatever each one is. Much less. So these two actually are bypassed. That's because there's a short to ground. So the path, the normal path would be the blue, splitting up here. The short to ground, you follow the green. Go through here, go through here, go here. It does not go into the light bulbs, neither one. It goes to ground, right? But before that happens, guess what happens? We have a protective device. It never gets to that point because this will blow as soon as, obviously, the current is rated more than the fuse. So therefore, on the regular one, on a normal situation, we have 12 volts here. The other side is 12 volts. Coming over here, we have 12 volts over here. If this would be a splice or a node, 12 volts over here, 12 volts over here, lining up your brake lights or your reverse lights, parking lights in the front or the rear, whatever. Always look for the connector 12 volts, 12 volts, 0 volts back to ground. That's the normal situation. Because of this, that there's a short, the current increased an amount that it just blew the fuse. So I'm going to have 12 volts here, and I'm going to have 0 volts over here. But to reiterate and to make a very important point, when I find a fuse and it's blown, when I find a fuse and it's blown, I just don't put back another fuse. I measure the resistance from this side of the fuse to ground. If I still measure 0 ohms from here to ground, I'm not going to put another fuse and blow that fuse. I'm just going to look and troubleshoot to see where there is a short. There's no purpose in putting in another fuse if it's going to blow when you still have a short to ground. Get rid of the short of the ground, then replace the fuse. Okay? Keep this in mind, a short to ground. Okay? Now let's look at this one. This one, not really a jumper, but there's a resistor with a very, very low resistance, 1/1000th of an ohm. Where do you think the current is going to flow? If this is 3 ohms and this is 6 ohms, right? The current will flow through this one. This has less resistance than this. This is the path has the shortest amount of resistance. This is a short to ground. Again, so the current in the normal stage through the fuse, from the battery, through this, splits up, goes here, splits up, goes here, and back to the negative. However, since we put a resistor with a very low resistance, follow the orange, goes from here through, right, here, through here, through here, through here, through here, but it'll blow the fuse. We'll never get to that point. Once it blows the fuse, because it exceeded the rating of 10 amps, it blow the fuse, 12 volts here, 0 volts here. Now, the other thing is, the other thing is over here, if you figure out how much, there's something called Ohm's law. If you figure out how much it is, if the total resistance is 1/1000th of an ohm, it's 12 volts over 0.001 will give you, guess how many amps? 12,000 amps. Obviously, we exceeded the rating of the fuse. We blew the fuse, and that's why the purpose of the fuse is there, to protect the lamps and any other load connected to it. If you would not have this fuse here, basically, if you have a jumper going from here to here to here, you know what you're jumping? You're jumping the battery. And obviously, the battery cannot give out 12,000 amps. Okay, now I'm going to make another video, and I got a message about someone asking about a TPS sensor, and I'm trying to get a schematic for that. Remember, when you adjust TPS sensors, they have to be accurate. If it's supposed to be 0.3 to 0.4 or whatever, depending on the make and the model, check the manual. Okay, don't leave it up to your own discretion. Check the manual, how much you have to adjust it for with the 4 wires. Use a good voltmeter, number one, with high input impedance, because you're measuring up to 1/100th of a volt. If it's supposed to be between 0.3 to 0.4 or whatever, for example, 0.3, 0.4, it makes a difference if it's 0.31, 0.32, 0.34, 0.35. If the throttle body, and I'm going off topic, but I was asked this, if the throttle body is, let's say, closed between, let's say, 0.5 to 1 volt, whatever it is, right? And then it opens up at 2 volts to 3 volts or whatever, depends on the system. Some have it open, wide open throttle from 4.5 to 5 volts. If it's 4.5 volts, the computer looks at 4.5, 4.6, 4.7, 4.8. You have to adjust it accurately. You can't just adjust it. If you need 0.4 volts, you can't adjust it to 0.6 and say, well, that's close enough. No. The computer looks at 1/10th, 100th of a volt. it'll make a difference to the air-fuel ratio. If you do not adjust it accurately, this being the reference voltage for the TPS for the computer, you will have problems hesitation problems, accelerating. You might even stumble before you accelerate. You might even, lock up. This controls the air-fuel ratio. If it doesn't see enough air because of the throttle position sensor, because it's not adjusting right, guess what? Less air, less fuel. So you press the pedal, you have a hesitation, eventually it'll figure it out and it'll give you the fuel. But if it's 0.4, it opens throttle, right? The computer sees at 0.4. 0.41 makes a difference. 0.42 makes a difference. 0.43 makes a difference. So you cannot adjust it. If I need 0.4, I can't adjust it to, okay, I'll adjust it to 0.5. No. The computer has these parameters in its program by the engineers. Every single thing is a different air-fuel ratio for the computer to look at. Again, Corolla has a different one. Make and model, they're different. Check the manual. I'm going off topic, but that's what I was asking. Make sure, otherwise you will have hesitation problems if you don't adjust your TPS sensor correctly. Use the meter, the proper meter. Do not use the cheap meters on eBay and all this. You might have to go to 100th of a volt, 0.42, 0.45, and 100th of a volt to adjust it correctly. Okay? I wanted to stress that point, even though it's off topic again. Thanks for the subscribers. I'm doing a little better with that. The views, obviously. It's a long way. I've only been doing this for a year and a couple of months, like I said. The other channels have been doing it for 12, 13 years. So, they do great what they do. They really do great work. That's what Scotty Kilmer, great channel, entertainment. But, he's been at it a longer time than me. And we'll see what happens. So, one step at a time. Subscribers, hopefully the views. We'll see what happens. Hopefully, with my luck, YouTube doesn't take away views from me. I might be in the negative for views. But we'll see, one step at a time. But remember, a short to ground. Because the next video is not going to be a short to ground. It's going to be a short from 2 points. And you're going to see the difference. And about the TPS sensor, again, you have to adjust it correctly. The PCM looks, or the ECM, looks for every single numeral. Like I said, 0.5, 0.51, 4.5, 4.6, 4.7, 4.8 makes a difference. Keep that in mind. Thanks a lot for watching.